All right, let's go ahead and get started. Remember, we will have our exam 1 on Thursday, so that's our first examination. It's going to be on paper. I will give you the question as well as the answer sheet, but you want to bring extra binder paper, just in case you need any extra paper for your answers. You can use your calculators. That's fine with me. I don't think you will need it because based on all the calculations that we have done in this class, we should not need a calculator. But if you feel more comfortable with one, you can just get a basic calculator. I don't think you will need a scientific calculator at all for this class. Cell phones will have to be turned off. Okay, so so please don't use your cell phone as a calculator. You can get a $2 calculator from Walgreens, and that should be sufficient for this class. It will be on paper. It's open book, open notes. In other words, everything that we have done up to this point, you can print out anything you want and bring it with you. If you find a good textbook that you know of, you can bring your textbook too. If you want to write your own notes prior to the class, you can bring that with you as well. You cannot use your computer during the exam. I know some of you probably have your own laptop computer, but since not everyone in the class has a laptop computer, I cannot allow the use of a laptop computer or any electronic device other than a calculator. Are there any questions about the exam at this point? No questions? So you definitely want to bring your pencils, or pens, okay, writing instruments. I would suggest, bring pencils in the eraser, just in case you need to erase something. There is a way to do it. I will bring extra paper, extra, question and answer sheets. So in case someone says, I want to start from scratch, and can I have another piece of paper? I will have some ready. The paper I bring will be pre-lined. In other words, I will have the grids already drawn, so that way you don't have to line everything, yourself. Okay, but you do have to write within the confines of the grid lines. So that's why you might want to practice your handwriting a little bit prior to the class, because most of us don't really handwrite most stuff anymore. So our handwriting can be a little bit rusty. How about your other classes? Do you still have to handwrite your answers in your other classes? Math? Okay. When I took classes in college, I was using the computer as much as I could, even for my math classes. So I learned how to do all the typesetting for something over something, the integration stuff and whatnot. And of course, it didn't help when I was in an exam. So I was, I had to handwrite something in the exam anyway. Are there any other questions about exam 1? About the material, the scope? Nothing? Okay, if there are no questions, we'll move on to a new topic. This is our new topic. It's about arrays. Okay, so this is about the right time to get into arrays. But before we talk about arrays, let's go ahead and go back and talk about how to find the maximum of certain variables. Okay? Yep, it's that topic again. I know most of you are getting bored by that topic already. Okay. So the first one that I want to go over is how to find the maximum of two variables. We kind of know that already. But this time I'll make it so that it's a little bit more general than before. If x is greater than or equal to y, then the maximum, which is z, will get the value of x. Otherwise, z will get the maximum of the other variable, because y in this case will be the larger one. And that's the code to find the maximum of two variables. Are there any questions about this algorithm? No? Okay, that's kind of boring at this point. Let's find out, how to find the maximum of 3 variables instead of 2. Okay, we talked about this too. So we have w being greater than or equal to x, and w is greater than or equal to y. Then w is the maximum of the 3, and we use w to update the z. This is not the optimal way of doing it, but it is one way of doing it. So I'm just going to use this way because it is easier to generalize. If x is greater than or equal to w and x is greater than or equal to y, then z gets the value of x because x is the maximum in this case. If w and x are not the maximum, then y has to be the maximum, and the last case does not need any conditions. Is that okay so far? These are some of the algorithms that we have gone through up to this point. So the question is, based on these two algorithms, do we know how to write an algorithm to find the maximum of 4 variables?
Yes.
Yeah, we can just kind of extend it, right? Let's say we have another variable called v, then the first condition only has to check for, make sure that v is larger than or equal to all the other variables. Then we can change z according to v. The next one will check for w, the next one will check for x, the next one will check for y, but we don't have to check for y because y has to be the maximum if the previous 3 variables are not. So we know the general way of doing this. Okay, it's not a problem. Do you think this is very scalable? In other words, is this approach, can we extend this approach to many variables? Okay, let's say we're dealing with ARC. Okay, we want to find out, who at ARC, which student has the highest GPA. Okay, what is the enrollment of ARC at this point? 30-something thousand, not 3,000, 30-something thousand. So does anyone want to write that code to find the maximum of 30,000-something students based on this approach?
No.
I certainly don't want to do it. Someone can do it, but it's not going to be me. Why not?
It's going to be long.
It's going to be long. Exactly. How many lines do you think that program is going to be? It's not hard to figure out. It's going to be 30,000 times 2 minus 1. Right? Because we have 3 variables here. Oh, excuse me. It's 30,000 times 2 plus 1. Okay, because we need 2 lines for each variable plus 1 for the end if. Okay? But that's not the worst part of that algorithm. What if we have 30,001 student at ARC?
You have to rewrite the whole thing.
I have to rewrite the whole thing. That's right, because every condition has to be changed. So that's not really the best way to find out what is the maximum, what is the highest GPA of all students at ARC. So that's why we have arrays. Okay, arrays can solve that problem relatively easily. So what I'll do is I will introduce the algorithm based on arrays, and then I'll go back and talk about the notation, because I just want to show you what it looks like when we have the tools of arrays. With arrays, it is a whole lot easier. Okay, we just have to initialize I to 1. We have to initialize m to a bracket 0. There's no need to copy it if you don't worry about copying it, because the algorithm is already in the notes, and I will also save this file later on. And then we have a loop while I is less than RA bar do. And then inside the loop here we have if m is less than a bracket I, then m gets a bracket I, and if I gets I plus 1, and while. That's it. Okay, now I understand that we have not talked about the notations. In other words, at this point we have not talked about how to use the square brackets. Okay, it is not the same as in mathematics. In mathematics, we use the round parentheses and then the square brackets and then the curly brace, as different levels of parentheses. In programming, the square brackets have a completely different meaning, so we'll talk about that later. This is also not the absolute value of A. Okay, bar A bar is another notation in programming, particularly in this class that has a special meaning, but it's not the same meaning as in mathematics. The bottom line is this code here. How many lines do we have? 8 lines. Okay, these 8 lines of code can be used regardless of the number of variables that we are dealing with. We can start with 1. We go to 2, we go to 3, we go to 30,000, we go to 30,001, and so on. The algorithm does not change. Okay? Now, I see that as a big advantage over the previous approach. Okay? So are there any questions at this point about the rationale of using arrays instead of just variables? Okay. So we can definitely see it as an advantage of using arrays when we try to find the maximum of a certain number of variables. So here we can switch back. Let me save the file first, make sure everything is saved. So we're switching back to the slides and start to talk about what is an array, because we talked about the why already. Now, an array is nothing more than a container of variables. It's just a container of values. The first thing you have to remember is an entire array can be seen as one single variable. Okay? So it can be handled as one single item if we want to. On the other hand, if we want to break it up into individual parts, we can also break it up into individual elements. So each item inside an array is called an element. An array has several attributes. We can describe an array using the following. All elements in an array must have the same type. So we cannot have different types in a single array. Each element is identified by a number, which we call an index. The index of the first element is 0. In other words, in programming, a lot of times we count from 0 instead of counting from 1. The actual reason of counting from 0 instead of 1 won't be clear until you take cisp300, the assembly programming class. Because at this point, it's just it's strange, how come we are always counting from 0 when we are programming instead of counting from 1? Now here, this comes the definition of the bar A bar. If A is an array, bar A bar indicates the number of elements in the array A. The last element in an array has an index of bar A bar minus 1 because we start counting from 0. And the last part defines what is the square bracket. An element with an index I can be any integer, in an array is represented as A bracket I. Now this is pretty an abstract description. The other way to look at this is to use an analogy. In other words, you can look at the variables we have done up to this point. Each variable, you can kind of look at it as a coffee mug. Okay? So previously we have variable names like X, as a coffee mug, Y as a coffee mug, and then we have variable Z also as a coffee mug. Each one is individual and it can contain its own level of liquid. In other words, you can empty out the coffee mug X, and coffee mug Y and Z remain completely independent. They can hold their own content. Are we doing okay so far? Each mug has its own name. So when we have to designate a coffee mug, we just have to say the name of the coffee mug and there won't be any confusion. The concept of an array is a box. Okay? It is a box. So now, instead of looking at individual coffee mugs, we draw a box. Okay? And the box itself has a name. Let's say we call this array A. A is the name of the box itself. What can we put inside the box? Coffee mugs. Okay? So inside A, let's say we just put 3 coffee mugs inside. Okay? So here's one, here's the second one, and here's the third one. Okay, I kind of need to look inside the box here because we have to find out how do we identify each one when the box itself has a name of A, but each mug inside the box does not have a name. Are we doing okay so far? Sometimes we can look at this entire box and say, I want to move this box from here to over there. So in that case, we are looking at the entire box as one single thing, as one single variable. Other times, we want to access individual items inside the box and say, oh, I want this coffee mug to be emptied out and I want this one to be filled up. That's when we need to use the indexing operator. In other words, this one, the first one, actually has an identifier, which is a number. It is 0. The next one has an identifier, it is 1, and then the next one has an identifier, which is 2. Okay, so now I can refer to each individual mug inside the box, because I can say, go to box A and give me the content of coffee mug 1 inside that box. Are we doing okay so far? Okay. In other words, when we say A bracket I, or A bracket 1 in this case, we are saying, which box are we referring to? Well, we are referring to the box called A, because I can have multiple boxes. I can have box A, box B, box C, and so on. So I have to call the name of the box first. But once I identify the box, I can also get to individual items inside the box using the square bracket notation. Whatever number you have here, you use it to designate which item inside the box do you want to access. Are we doing okay so far with the notation? So A bracket 1 refers to box A, the coffee mug with 1 as a label. What is the bar A bar notation in this case? Bar A bar in this case equals to 3 because we have exactly 3 items or 3 elements inside this array. So is the general notation okay at this point? Now what is kind of interesting is inside the square bracket, this part here inside the square bracket does not have to be a constant. It doesn't have to be 1, doesn't have to be 0. It can be a big, huge, long expression. In other words, if you have the need, you can take this, the content inside the square bracket can be something like x times 3 minus y, the whole thing divided by z plus 1. As long as this gives you a valid integer value, in this case 0, 1, or 2, it is fine. Are we doing okay so far with this concept?
So it has to be an integer at the end, it can't be like a float or something?
Correct. It has to be an integer inside the square bracket. And in order to get to a actual coffee mug, it also has to be within the range of numbers that makes sense. So in this case, since I only have 3 elements inside the box, this number or the value inside the square bracket can only be 0, 1, or 2.
Okay, so but that's the actual name of the elements in the array, but the actual values that those elements have could be of other types?
The value inside the coffee mug can be anything.
Oh,
That's
okay.
correct, as long as they're the same type. So if you think about it, in the case of a container, that means you can only have either all coffee mugs inside the box or wine glasses inside the mug, or whatever container you want to use, but they all have to have the same shape, intended for the same type of liquid. Okay. So are we doing okay so far with the concepts? Yes? Okay. So with this already kind of cleared out and out of the way, we can go back and take a look at the algorithm that we looked at already, which is this one here. And we'll just kind of quickly go over what it is actually doing. In this case, you have to be given an array. In other words, array A must have a fixed number of elements already by the time it runs, and every element has to have an initial value, because otherwise you cannot find the maximum of unknown values. This statement just takes one element out of the entire box and say, I will use its content to initialize my variable m. This part here says as long as I is a valid index, stay in the loop. Now I know that I has to be a valid index as long as this condition is true, because I was initialized to 1 to begin with. And as long as I is less than bar a bar, I still have a valid index, because the indexes of elements inside an array goes from 0 all the way up to bar a bar minus 1. That means as long as I is an integer and it is less than bar a bar, it is still a valid index, because it starts with a value of 1. And then over here, I compare m, which is my own variable here, to a particular item in the box. If the value of the item in the box is larger than m, then I update m to be the value of that item in the box. In other words, if I find an element in the box that has a larger value, that becomes my current maximum, because it's larger than everything that I have seen so far. But I also have to remember to add 1 to I at the end of the loop so that I can advance to the next item to take a look at the next item in the next iteration. At some point, I will become bar a bar. When I does equal to bar a bar, this condition will become false, and then we get out of the loop. Are we doing okay so far with the general concept of the loop? Let's go ahead and trace it, because the best way to really understand a construct is to trace it so that we not only do we know how the program executes, but we also know how the data is represented. Yep.
What if we wanted to know which student had that?
That will require a slight change to the algorithm. Instead of using M to remember the largest value, you can use M to remember the index of the largest value. But the program will have to change a little bit in that case. I can show you, that variation as well, but let's focus on this one first, and then we'll talk about the variation.
Okay.
That's a good question. So we'll go ahead and just rewrite the algorithm here. I gets initialized to 1. Now, it doesn't have to be initialized to 1. It can be initialized to 0. It's just that if you initialize it to 0, it is somewhat redundant. You waste one iteration for doing nothing. And then we have M being initialized to A bracket 0. While I is less than bar A bar, do if M is less than A bracket I, M gets A bracket I. I gets I plus 1, and while. And then we'll go ahead and fix the indentations. So we have our algorithm here. Next, we have to trace it. I will use a separate window for the trace. We have conditions to evaluate, so we need comments. We have line number, these are all mandatory. We have our two variables I and M. But now we also have to remember that we have to initialize, or we have to represent the array A. Let's start with 3 elements in A. We don't want to start with a whole lot because it's kind of monotonous after a while. So we'll say we have A here. However, remember A is not a single item. A is an array. So that means when I say A, I have to also be clear about how many elements do we have in A and what are the individual values of each element of A. And that's why I need to designate one column for A bracket 0, one for A bracket 1, and one for A bracket 2. In other words, every single element in A gets its own column because it has its own value. Are there any questions at this point about why I allocated 3 columns? Yep.
Yeah, why is there only 3 of them? How did you determine?
It's just that for this example, I only use 3, but it can be any number. Okay, but it has to be fixed by the time we run the algorithm. So in this case, I have to give these individual items a value because otherwise I can't find a maximum of 3 unknown values. It doesn't make any sense to compare a unknown to another unknown. So in this case, what I have to do is to give these guys specific values. I'll give this one 2, this one 6, and this one, let's say, 4. Doesn't matter. Okay. This should cover some of the interesting cases inside the loop already. M does not need a specific value to begin with. I does not need a specific value to begin with because they all get initialized in the program itself. And we start, this is the precondition. Are there any questions about how I set up the trace at this point? Is everything okay so far? A only has 3 elements only because I set it up this way. Okay. Did that answer your question? Yep. Go ahead. Go ahead. Yep.
I was just wondering, where in the code does it state that there's 3 elements to add?
That depends on the programming language. In some programming languages, you can make the array larger and smaller as it goes. But for this class, we'll just say that it will stay put. It will stay exactly the same size during the execution of the algorithm. Because in C++, if you use a vector, you can actually change the size of the array on the fly. And if you use PHP or Perl, it's the same way. You can change the size of an array on the fly, which creates problems in a way.
But I'm just thinking, is there something that I'm missing? Is it actually defined in the code somewhere?
No, this is a precondition that has to be given to you.
Oh, okay.
In other words, this has to be a precondition. I have to give this to you because otherwise there's no way for you to know when to stop the execution. Because if you don't know what bar A bar is, then there's no way you can compare I to bar A bar. And that's why it has to be fixed in order for the algorithm to work. Good questions? Are we ready to execute the algorithm? Okay. We start with line 1. Line 1 is pretty easy. Now remember, in this algorithm, I and M are basically the same as all the other variables that we have dealt with at this point. They are no more special than, say, variable X in the previous algorithms. Okay. So I is nothing more than just a normal variable. It gets initialized to 1. Now here comes line 2. Line 2 is pretty easy because the right-hand side of the assignment statement spells out exactly which one I want to refer to. I want to use A bracket 0. A bracket 0 is column E. It has a value of 2. And that's why variable M, which is also not a very special variable, starts with a value of 2. Are we doing okay so far? Okay, nothing is too special at this point, except when we refer to A bracket 0, we can use A bracket 0 as if it is just any variable because it has a value. We go to line 3. Line 3 is checking the condition I is less than bar A bar is
True.
It is true. What is bar A bar, by the way?
3.
Bar A bar is 3 because we have 3 elements in array A. We go to line 4. Line 4 is a little bit more interesting because the condition we are evaluating is A bracket is M less than A bracket I. Okay. Now here it's a little bit more special because if you just look at this expression here, M is less than A bracket I, you don't know the result of the comparison. You have to know what I is first. So we look up what is I, the value of I. I currently has a value of 1. So A bracket I is actually referring to A bracket 1. Are we doing okay so far? Whatever expression is inside the square bracket, you evaluate that expression when you need to find out what is A bracket whatever. In this case, it is A bracket I, and right at this point, I has a value of 1. So we are actually comparing M to A bracket 1. A bracket 1 has a value of 6. M has a value of 2. 2 is less than 6 is true. Are we doing okay so far with this step? Questions? No questions? Okay. If the condition of the conditional statement is true, we go ahead and execute the then branch of that condition. In this case, the then branch is just updating the variable M with the value of A bracket I. Once again, we evaluate, okay, this is on line 5. We evaluate I on the fly when we execute line 5. I at this point has a value of 1. So that means M is getting the value of A bracket 1. A bracket 1 is column F. Column F has a value of 6. So M is now updated to a value of 6. Are we doing okay so far? The key is, when we evaluate A bracket I, such as on line 4 and line 5, it is evaluated on the fly using the value of I at that point. Okay? The next iteration will make it more clear because in the next iteration, I is not going to have the value of 1 anymore. It will move on to a value of 2. After line 5, we get out of the conditional statement. We go to line 7 to continue execution. I gets incremented to a value of 2, and we go back to the beginning of the loop, which is on line 3. And then we ask the question. I is less than bar A bar is true because I is 2, bar A bar is 3, and 2 is less than 3 is true. We go to line 4 again. Line 4, the condition of line 4 does not change. It is still asking, is M less than A bracket I? But this time, because remember, we evaluate the expression inside the square bracket on the fly using the values at this point of time. That means, this time on row 11 of the trace, what is the value of I at this point? It is 2. So that means we are no longer comparing to A bracket 1. This time we are comparing to A bracket 2. A bracket 2, which is column G, has a value of 4. M has a value of 6. 6 is less than 4 is false. Okay. So that means we don't get into the conditional statement. We skip around the conditional statement and go to line 7. Line 7 is going to add 1 to I. I gets incremented to 3. We go back to line 3 again. Line 3 this time asks whether I is less than bar A bar. The answer is false, because I is 3, bar A bar is also 3, 3 is less than 3 is false. And then we get out of the loop, and we get the algorithm terminates. Are there any questions at this point? Because this is the first illustration of how to use arrays, particularly the A bracket notation and also the bar A bar notation. Are there any questions about this algorithm at this point? No questions? This is all good? Okay. So let me save this first to today's folder. And I'll save this one as find maximum value, because the next one, it will have a slightly different name. The next algorithm will look like this. The next algorithm will look almost exactly the same as the one before, except I change it only slightly. But enough to make it different. Okay, so this time let me save as a different name. This time I save it as find max index, because this time I'm finding the index of the largest element instead of the value of the largest element. And then we go back here, we erase everything, we start from scratch. All right. So first of all, let me just explain the differences between the value versus the index. If you just look at column F, okay, we just focus on column F here. The index of the element is what? It's 1. Okay, 1 is the identifier of that element inside the array. What is the value of the element? 6. 6 is the value of the element. Okay, so last time we were only interested in the value of the maximum. In other words, we look at 2, 6, and 4, and then we ask what is the largest value of these 3, and the answer was 6, and we found that answer just fine without any problems. This time, however, we are not interested in the value, we are interested in the index. In other words, out of index 0, 1, and 2, which one is the identifier of the element that actually has the largest value? Why do you think sometimes I might be interested in the index instead of the value? Well, first of all, if I know the index, can I find the value?
Yes.
It's easy, right? But why do I want to find the index sometimes? If I know the index, I know where to find the element. And sometimes knowing where to find the element is useful, okay? Especially when you're using sorting algorithms. So we'll talk about sorting maybe later on in this semester. So at this point, we want the answer to be 1, because 1 is the index of the element that has the largest value of the 3. And then we'll start running the algorithm just like before. Line 1 initializes I to 1. Line 2 initializes M to 0. Now this is a good time for me to just stop a little bit and explain what is the role of M. The role of M is to keep track of the index of the element that has the largest value at this point. In other words, if I have just seen one single item in the entire array, the first one, I cannot know whether it is the largest one or not, but I know it is the largest one at this point because I've only seen one element. So M is the index of the largest element that we have seen so far, starting from the beginning of the array. We scan to the end of the array. We go to line 3. Line 3 does not change from last time because we're still comparing I to bar A bar. So I is less than bar A bar is true. We go to line 4. Now this time it is a little bit different. It has the same result as last time in terms of the result of the comparison, but the mechanism of the comparison is no longer the same as last time. Because this time, when you look at this comparison, both sides of the comparison use a variable inside the square bracket. So this time, I have to look at m and I on the fly on row 7 of the trace and ask myself, what is the value of m at this point? I look it up, m has a value of 0. So that means the left-hand side of the comparison is referring to a bracket 0. I look at the right-hand side, a bracket I. I look up the value of I at this point, I has a value of 1. So in this case, I'm comparing a bracket 0 to a bracket 1. A bracket 0 has a value of 2, a bracket 1 has a value of 6, 2 is less than 6 is true. Okay. So the result of the comparison is the same as last time, but the way I compare is different. Then I go to line 5. Line 5 is definitely different this time. Last time, I'm copying the value of the array element to m. This time, I'm only copying I to m. I has a value of 1, m ends up with a value of 1. Are there any questions at this point? Remember, I is just a regular variable. M is just a regular variable. How I use I and m is a little bit special in this case. So it is the use of the variable that makes it special. The variables themselves are no different than any other integer variables. I go to line 7. Line 7 does not change from last time. It goes from 1 to 2. The value of I goes from 1 to 2. We go back to line 3. Line 3 does not really change. It is still true this time because 2 is less than 3. Then we go to line 4 again. On line 4, we are still doing the same comparison, except this time the result is false. Now, why is it false? Well, we cannot just say that because last time it was false in the second iteration, therefore this time it is false. We have to look into this comparison and ask ourselves, what are we comparing? The left-hand side of the comparison is referring to a bracket m. I look up the value of m at this point. M has a value of 1. So the left-hand side is actually just referring to a bracket 1, which has a value of 6 at this point. The right-hand side is referring to a bracket I. I look up the value of I. I has a value of 2. So we are comparing a bracket 1 to a bracket 2. A bracket 1 has a value of 6. A bracket 2 has a value of 4. 6 is less than 4 is false. That's why we skip over the entire conditional statement. We go to line 7. We add 1 to I. I goes from 2 to 3. We go back to line 3. I is less than bar A bar is no longer true. It is false now. And then we get out of the loop. Are there any questions about this trace at this point? So does this answer your question? Okay, good. So I'll make sure that we save this one too. Remember, the two files are named differently. One is called find max val for value. The other one is find max index for finding the index of the maximum element. Okay, so let's go ahead and work with another example. Okay, because it's the examples that makes us understand or help us understand the concepts. This time, let's start with this one. This time I have a bracket 0, getting a value of 1 to begin with. I have I as usual, and I goes from 0. And I intentionally make this one a little bit kind of convoluted. Okay, so this time we compare to bar A bar minus 1. And inside the loop, I have a bracket I plus 1 gets the value of a bracket I plus a bracket I gets I plus 1, and while. And we'll go ahead and find out what this actually does to the array. Let's not give it a name first, because if I give it a name at this point, you guys will know exactly what it does, and that kind of spoils the whole thing. So I won't give it a name, and we'll go through a trace to find out what it does. Then we'll name the file accordingly. We have comments, we have line number, we have one single regular variable I, and then we have A. This time, let's say that A also has, well, let's make it 4 elements. Okay, I don't know. 3 is fine. Okay, we'll just stick with 3 elements in this case. Whenever you trace something like this, the number of elements has to be predetermined. You cannot say that I don't know the number of elements before the algorithm starts, because in order to compare to in order to compare to bar A bar, you have to fix the number of elements when you run the algorithm. So in this case, the number of elements is just 3, just like last time. And then we'll go ahead and I have to give you a precondition. The precondition is I don't know anything about I, A bracket 0, A bracket 1, or A bracket 2. The only thing I know is A has 3 elements. That's the only thing that I know is that the array has 3 elements. So I'll just go ahead and merge these 3 cells into one just to make it clear that A refers to columns D, E, and F. A bracket 0 refers to a single column. Are there any questions about this one at this point? Okay, if there are no questions, we'll go ahead and find out what it does. Line 1 is fairly easy. It's just a regular assignment statement. It is pretty clear which column we have to update because A bracket 0 is column D. Column D has the name of A bracket 0, so that gets initialized to 1. Line 2 is just initializing our regular variable I to 0. Line 3 is a little bit more convoluted than last time, but not much more, because we are comparing to bar A bar minus 1 instead of bar A bar itself. Is that true or is that false? It is true, because what is bar A bar minus 1? Bar A bar is 3, 3 minus 1 is 2. And I is 0, so that means 0 is less than 2 is true. We go to line 4. This time, line 4 is the problematic line. Okay? I shouldn't say problematic, but it's the more interesting one. How do we look at this line here? How do we find out what it's going to do? Well, first of all, it is an assignment statement, right? It has the left arrow symbol, it has a right-hand side and a left-hand side. So with any type of assignment statement, what is the order of doing things? The first thing is to evaluate the right-hand side first. The right-hand side is basically 2 times A bracket I. What is I at this point? You look up the column on row 7 of the trace. You look it up and you say, oh, I has a value of 0 at this point. So A bracket I refers to A bracket 0. The right-hand side becomes A bracket 0 plus A bracket 0. A bracket 0 has a value of 1, so the right-hand side is just 1 plus 1, which is 2. What are we doing with the value of the right-hand side? We use it to update the left-hand side. What is the left-hand side this time? The left-hand side is A bracket I plus 1. What is I? I is 0. 0 plus 1 is 1. 0 plus 1 is 1. So the left-hand side is referring to A bracket 1. A bracket 1. So A bracket 1, which is column E, is now updated to a value of 2. Are we doing okay so far? In terms of concept, I know when we have to spell it out and actually say what it is, it's a little bit cumbersome. But is the concept clear?
Yeah.
Okay, the concept is clear. Okay, it's just important to remember to evaluate I plus 1 first. Okay, whatever the value of I is, just add 1 to it. It becomes the result of the expression. Use the result of the expression inside the square bracket to tell you which element of A I want to access as the left-hand side. Well, since I is 0, 0 plus 1 is 1, so the left-hand side is A bracket 1. A bracket 1 is column E, and that's why we're updating column E to the value of 2, because 2 is the result of the right-hand side. We go to line 5. Line 5 is the usual line. We're just adding 1 to I. We go back to line 3 again. I this time is 1, is less than bar A bar minus 1, which is 2, is still true, so we go to line 4 again. What are we doing this time? Well, same thing. We have to evaluate the right-hand side first. What is the right-hand side? The right-hand side is a bracket I plus a bracket I. The expression is the same, but I has changed. Okay, that's why array indexing is so powerful. You can look at the same statement. This statement has not changed from the previous iteration, but since I has changed, what we are referring to also has changed. So this time around, on row 10 of the trace, a bracket I is referring to a bracket 1 because I has changed the value from 0 to 1. So the right-hand side is a bracket 1 plus a bracket 1. A bracket 1 has a value of 2. So it is essentially 2 plus 2, which is 4. What are we doing with the value of 4? We want to use that to update the left-hand side. The left-hand side is a bracket I plus 1. But once again, I has changed. I has now has a value of 1. 1 plus 1 is 2. So this time we're updating a bracket 2. A bracket 2 is column F, and that's why column F is updated to a value of 4. Okay. We go back to we go to line 5 first. We add 1 to I goes from 1 to 2. Then we go back to line 3. I this time is 2. 2 is less than bar A bar, which is also 2, is false. And then we get out of the loop, and that's the end of the trace. Are we doing okay so far with this one? Yes? Okay. So the magic, remember this time it is more clear about the magic of array indexing. The magic of array indexing is the statement can look exactly the same, but what it does can change depending on the value of the expression inside the square brackets. With something like line 1, it doesn't matter because inside the square bracket, we have a constant, 0. 0 does not change over time. But when we are talking about line 4, it is changing because I changes with each iteration. And that's why with each iteration, we are referring to 2 different elements. The right-hand side refers to the one before, and the left-hand side refers to the one after. Are we doing okay so far with the concepts of array indexing? Is it okay? Okay. Let me save this file first, and then we'll go to another yet even more confusing example. Okay, let's go to, this is, okay, we'll just call it doubling, because each element is the double of the one before. Okay, close this one. This one, and we'll go ahead and start with another spreadsheet. This one is interesting because I only give you one line to trace. This one line to trace is to print a value because I have to do something with the value that I have as a result. So it's just printing it out. But what I'm printing out is the interesting part. Oh, I'll just make it 1, 2, 3, 4. Okay, so this time we have a very simple algorithm to trace. The program itself is kind of simple and also kind of complicated and convoluted in a way. The magic of this program is how are we going to make the array, because I have to make the array to make this work. Comments, line number, and we have array A. Let's just say that we also have 3 elements in this case in A. A bracket 0, A bracket 1, and A bracket 2. This time I have to be careful about the values in array A. So I'll make this one go to 0, this one to go to 2, this one to go to 1. Okay. That will work. So the question, okay, this is the precondition. In other words, as a precondition, I have to give you, basically 4 things. I have to tell you first how many elements do we have in A. And then I have to tell you the initial values of the elements in A, because otherwise you cannot evaluate the expression on line 1. The question now is, on line 1, what are we printing? What is the value that we are printing out? Well, let's work on this one step by step. Okay? In other words, I'll make this one kind of long here. I will copy the exact statement first. A bar, A bar, bar A. Okay. This is the original thing. When you work on math problems and you have many levels of parentheses, what do you do with those levels of parentheses? Which one do you start with? Do you start with the outermost or do you work with the innermost first? The innermost first. And it's the same way here. Okay? So the innermost one is this one here. A bracket 1 is nested in the innermost portion. What is A bracket 1?
0.
That's just 0, right? I mean, okay, so let's go ahead and copy and paste it. Except this time, we replace this whole thing with 0. Okay? And we're still on line 1. I'm just breaking up line 1 in multiple steps itself. All right, this still looks kind of nasty, but it is now one level fewer than last time. Copy and paste. So this time we also work with the innermost part of the nesting. What is A bracket 0? Look it up. It has a value of 2. Okay, that's fine. The whole thing is starting to clear up a little bit here. What is A bracket 2? It's a value of 1. And let's do the last step here. What is A bracket 1?
0.
It's a value of 0. So that means this line, the one single line that we have in the algorithm, will print a value of 0. That's it. It just prints a 0 to the screen or on a piece of paper, and it doesn't do anything else. But is it clear now that we can have anything inside a square bracket as long as 1, it has to be an integer, and 2, it has to be a value from 0 up to bar A bar minus 1. As long as it is one of those integers, we are still doing okay. Is that okay so far? Any questions at this point? No questions? Okay. So let's go ahead and save this one too. I'm actually kind of surprised that there are no questions up to this point. When there are no questions, it makes me worry. This is nested indexing. Let's look at this one here. This one is not something that we can actually trace, but the question is still, there's a question. Okay, so I'll just make this one looks like this. Okay, I gets a value of 3, and we say A bracket I gets a value of 6. This is line 1. This is line 2. So the algorithm is really simple. I mean, by our standard, up to this point of this class, this is like totally predictable. We should know exactly what it does. Well, not quite, because this is the way I will give you as the precondition. As the precondition, and I'm not sure whether I'm going to put comments here. Now, there's no big restriction of whether I have to put A first or put I first. So in this case, I'll put A first. And I'll say A still have 3 elements. We have A bracket 0, A bracket 1, and A bracket 2, and then we have our regular variable I here. And someone can can say that, oh, there's a problem right away, because what is the problem? Can someone tell me right away what the problem is?
Because A3.
There's no A bracket 3, right?
Yeah.
Because array A only has 3 elements. Okay? And I can give you specific values to begin with. Okay, so make sure that's not the issue. So I have specific values like 15, 9, and 10. Doesn't matter. And I can start with an unknown value. This is my precondition. Give it a column for line number. And here's my precondition. Line 1 is not a problem. Line 1 is just going to initialize I to 3. Line 2 is a problem. Okay? What do you think will happen when line 2 executes? Go ahead. Okay, we're looking at a box, okay, because A is a box, just like here, and the box has exactly 3 elements, just like here. The elements inside the box are A bracket 0, A bracket 1, and A bracket 2. If I had A bracket 3, where do you think A bracket 3 would be?
Outside.
Would have been. It would have been next to A bracket 2, right? It makes sense, right? Because they're all sequential. They're next to each other. So this time what we have is we have another coffee mug here outside of the box that has a name of I. Okay? It's just the way I arrange the variables, okay? Because on the shelf, I have to put all the coffee mugs and all the boxes in a particular way, and this time I just chose to put the boxes in this way. I have the box of A, on the left-hand side, followed by the coffee mug with the name of I. So when this when line 2 executes in this code, it all depends on the programming language. Different programming languages will do it differently. And there are at least 3 ways that this can happen. Okay, so let's go ahead and take a look at how this can happen. What line 2 actually is going to do. Okay. So this is kind of interesting because it all depends on which programming language you're using, and the result is different. So I will start with how should I do it? Do you want me to put the explanation here, or do you want to put the explanation in the text file? I can do it either way. Over here? Okay. I'll probably have to push it all the way over so it's easier to look at this one. So I have to turn on rapid text automatically. Okay. In C, column F will be used as A bracket 3. Let me just show you the code and also the trace at the same time. Okay?
I said, are you allowed to do that?
Well, because the C and C++ programming language is fairly simple-minded. When you say box A, okay, you're only telling the C programming language where is the beginning of box A. Okay? So when you say box A and item 1, it knows, okay, it's 2 items to the right-hand side. No problem, I can find the coffee mug. When you say A bracket 2, it knows it's 3 items, and it can find the coffee mug. When you say A bracket 3, hey, it's not a problem, because if I know, if I know that array A starts with column C, then A bracket 3 is going to be column F. And that's exactly how a C or C++ program is going to do, is to access column F, which is our variable I, as if it is A bracket 3. A bracket 3 actually does not exist, but it will misinterpret column F as A bracket 3, which is not a good thing. Okay? And it will do it silently. In other words, it will access column F, which has a value of 3, and and change this to 6. In other words, if I do this in C on line 2, this will change to 6. That's exactly what a C program will do. Now, later on, if you just look at this program here, okay, let's not look at the trace, let's just look at the program. Does this program do anything to I itself? No, it does not do anything to I. So that means later on, if you try to use I, if you just look at the program, you will think that I will still have a value of 3, right? That makes sense, because it was initialized to a value of 3, and it should still have a value of 3, let's say on line 3. Excuse me. But you run the program, when you actually run the program, that's not the case anymore, because when you actually run the program, line 2 will accidentally change the value of I because it thinks column F is also A bracket 3. And this is probably one of the worst thing about the C programming language, is it does not know the boundary of arrays. And it will allow you to access elements outside of the boundary of an array. It will just go ahead and mess up something. Okay? Do we have any questions about why in the C program it will do something like this? No questions? Okay. Let's talk about in some other programming languages. In VB, or Visual Basic, the program will stop and print an error message. And this is probably by far the best response. Okay? If you try to run this program in Visual Basic, it will give you a runtime error. Okay? The runtime error will come in the form of popping up a dialog box on the screen, and it will say on which line of which program it is trying to access an array out of bound. And that's the best thing that can happen, because it complains about the problem right when it happens. Whereas in the C program, it silently will do something that is wrong, except the symptom of doing something wrong won't show up until much later on when you actually use the variable I. Does it make sense so far? Okay. But there's more. In PHP or Pro, the size of array A will get extended when A bracket 3 is referred to. Now that's kind of interesting, because what happens in PHP or Pro is to do something like this. Okay, so I have to copy the entire header over here, because what it will do is it will do something like this. That's what it will do in PHP and Perl. It will say, oh, you want to access A bracket 3. Let me see. I can find A bracket 0, A bracket 1, A bracket 2, A bracket 3 is not a part of the box yet. Let me make the box bigger and give you a new coffee mug and put it inside that box. That's what PHP and Perl will do. So that means your bar A bar is also going to change accordingly. Because now, when the array has 4 elements, bar A bar is now 4. Okay? So when you have a loop to compare to bar A bar, you can potentially make a mistake to turn the loop into an infinite loop, because every time you get back to check whether you're out of the box already, the box just got bigger because of the content inside the loop. And therefore the box will get bigger and bigger, but you will never terminate the loop. It will get out at some point, because your program will crash out when your system runs out of memory, because the box is going to get so big that even 4 or 8 gigabytes of RAM is not enough anymore. It's going to take a while. Okay, so do we have any questions about this program? This is an intentionally buggy code to illustrate what happens when you execute the same code but in different environments. No questions? How many people are moving on at some point anyway to take the C class? I think the majority of the class is going to take cisp300, which is C and C++. So this is what you need to know, because it will silently destroy something else, and until you use that something else that you destroyed, you won't even know that something bad has happened. Now this is already something that's nice, okay? It's actually stepping on a variable itself. Sometimes it does not do that. Sometimes it steps on something that is not a variable of any kind, but is used for system functions. I cannot quite explain the concept until we get to that point. But it can change the behavior of your program mysteriously. That if you just look at the behavior of the program, there's no way to explain why it behaves that way. Okay, I have not talked about subroutines yet, so I cannot explain the symptom. But by the time we get there, maybe we can talk about that. Any questions at this point about array indexing? No? Okay. How many people have already taken the class in Visual Basic? Okay. So Visual Basic has the best response to this kind of problem. PHP and Perl try to be smart, because they say if you try to access an element in an array, It will expand the array to have that element start to exist, but it will break certain algorithms because of that. Okay, so let me save this file first. And I will call this out of bound, because we are accessing an array out of bound. Right. Let's go ahead, since we still have some more time, I'll give you more examples, because the more examples we go through, the better. So the next example I give you is an algorithm to see if an array is sorted. Do we understand the concept of a sorted array? So, okay.
Does that mean that it's all the elements are in order?
Yes, they all have to be in order. So we'll go ahead and create another spreadsheet for this. And instead of giving you the code first, this time I'll give you the columns first. So we'll have columns, my number, I, I'll call this sorted, and I'll give you array A. And let's say array A has 4 elements. Okay. Okay, so if you look at this sequence here, is that sorted? It is sorted. How would you describe how these 4 values are sorted? Sequential,
Oh, series.
from small number to big numbers.
Ascending values.
Ascending values. I would call this non-decreasing order. Okay? Now there's a slight difference between ascending versus non-decreasing. Ascending means, the 2 elements next to each other, they must be in an ascending order. But 2 and 2 are not exactly ascending because they're exactly the same. So I would call this non-decreasing because 2 is not less than 2, and it's fine. 2 versus 5, non-decreasing is fine. 5 versus 6, non-decreasing is fine. Okay, so it's just a little, being picky about, how I describe this array. Okay, so this is a sorted array. I have a variable here called sorted. I have my I variable, which is, my index variable, and this is my precondition. So now I go back and try to write the code to actually do it. First of all, let me ask you a question. It doesn't happen with this particular array, but let's say the array is not sorted. Can I get out of the loop and say, oh, the array is not sorted, let's quit here? Yeah, because once I confirm the array is not sorted, I don't need to look at the rest of it. So this is how the algorithm goes. The algorithm will start with I being 0. In other words, I will scan from the beginning of the array all the way to the end. And I would use sorted as a Boolean variable. Okay, in other words, I will say that it is initialized to a value of true. Is this the first time that we see a variable initialized to a Boolean value?
Yeah.
Yep. Is there a problem? Can we do this? It's not the problem. Okay? A variable can be used to store a numerical value, but just the same, I can also make a variable store a Boolean value. It can be true, it can be false. So this is the first time we see it, and we'll see it more often later on too. And the way the loop works is, while I is less than RA bar, do the following. Okay, I'll do it the dumb way first, and then we'll do it the smarter way. In fact, I'll do it the very dumb way first. Okay, I will say if sorted. Okay, this is the absolute dumbest way to do it. If A bracket I is greater than A bracket I plus 1, and I missed one thing here. This has to be A bar minus 1. Then we'll say sorted is false. And if, let's just take a look at these 3 lines first and see whether that makes sense or not, just by itself. Okay? Does that make sense? I want the array to be sorted in a non-decreasing fashion. Okay, non-decreasing fashion means something like this. This is non-decreasing. So if I find that a bracket I, which is some element, is greater than the element to its right-hand side, that means the array is not sorted in a non-decreasing way. Is that right? So that means the array is not sorted, and it makes sense to change the variable sorted to a value of false, because we have just found that it is not sorted, right? Is that okay so far? Okay. And then we'll say and if or I gets I plus 1, and this is not going to get the job done, and I will explain why it is not getting the job done yet. Okay, you look at and while sorry. We look at this loop here, and we know it is not going to get the job done, because what if a later part of the array, the last two elements that we compare, is in order? Well, I guess it will get the job done because sorted never gets a chance to become true again. So it will work, but it's not the best way to do it. Let's go ahead and just run this one first, and if we have time, we'll find out how to make it slightly more efficient. So we start with line 1. Line 1 initializes I to 0. Line 2 changes the variable sorted to true. And then on line 3, we can do the comparison. I is less than bar A bar minus 1 is true, because bar A bar is 4, 4 minus 1 is 3, and I is 0. We go to line 4. Okay. Line 4 is A bracket I is greater than A bracket I plus 1. Okay, what are we doing here? In other words, what am I going to write when I try to comment it out? Try to write the comment. A bracket I is greater than A bracket I plus 1 is what? Well, first of all, what is I? I is 0. So what are we comparing? We're comparing A bracket 0 to A bracket 0 plus 1, which is 1. In other words, we are comparing A bracket 0 against A bracket 1. Is A bracket 0 greater than A bracket 1?
No.
No. So the answer is false. So we get out to line 7. We add 1 to I, and it will look like this for the next 3 iterations, because the array is in fact sorted. So we won't have a chance to step on line 5 at all. We go back to line 3. Line 3 is going to say it is still true. We go to line 4, it is false again. We go to line 7, we add 1 to I, and then we basically do the same thing again. Okay, I'm just being lazy here. This time it is 3. We go back to line 3. The condition is now false. And then we get out of the loop. Is that making any sense? Okay. Okay, great. So it doesn't really show any usefulness. I mean, this seems to work fine. Let's go ahead and change the way we initialize everything. So I'm just going to copy this to sheet 3 for our next test case. This time we'll change it to in a way so that our current mechanism is not smart anymore. We'll just make this 3. Okay, I don't need to make this very different from last time. Just make it 3 is enough to illustrate my point. Okay, we start with line 1 again. And okay, line 1 is still doing what it used to do. Okay, I gets initialized to 0. Line 2 still does what it's supposed to do. Sorted is true. And then on line 3, same as before, I is less than bar A bar minus 1 is true. We go to line 4. And what is the result of line 4 this time?
It's true.
It is true because I is 0. A bracket I refers to A bracket 0, which is 3. I plus 1 is 0 plus 1, which is 1. A bracket I plus 1 is now referring to A bracket 1. 3 is greater than 2 is true. So now we go to line 5. Line 5 says sorted is false. Okay, so we change the variable sorted to false. And then we get out of the conditional statement. We go to line 7. Line 7 adds 1 to I goes from 0 to 1, and we go back to line 3, and the condition is what? It is still true. Because I is 1, bar A bar is 4, 4 minus 1 is 3. But do I really have to go through another iteration? If I know the first part of the array is not sorted, can I say the entire array is not sorted? Yes. So it is not wrong to go through the rest of this program. It's just not necessary. I'm wasting the next 2 iterations doing nothing because no matter what it does, sorted will stay false. How do I know sorted will stay false?
Because you already have one false, right?
Well, I already have one false here. Do you see anything inside the loop here that can change sorted to true? The only assignment statement is line 5, and it can only make it false. So there's no way to turn sorted to true again. So I should be exiting right now on line 3 because now that I know sorted is false, I should get out already. Okay, so here's the question. How can I change this algorithm to make it smarter? So let me save this one first. And I'll call this check sorted 1. And here's the second iteration. Because I want to get out here. The question is, how do I get out early? Okay, so let me save it as check sorted 2 so that I can describe the algorithm. I have to change something about this condition here.
You can just say and sorted is true.
And sorted is true. Okay, very good. Okay, and sorted is true. Now, but I can make this even better. Because does everybody understand why this will basically make the algorithm exit earlier? Because as soon as sorted becomes false, this will become false on the conjunction. But if one side of a conjunction is false, the entire conjunction is going to be false. So that means after the first iteration, after I confirm that 3 is greater than 2, I won't have to get through the second iteration anymore. So that's great. That is great. But I can also change this condition a little bit because when sorted itself is a Boolean, I don't need to compare that to true. Does that make sense? Sort of? No? Kind of? Okay. Okay, let's take a look. I think we'll just use the remaining 2 minutes to explain this one here. Okay, let me... Okay, obviously this part has to change, because I have to say and sorted. It's true. But in the second iteration, it is not. Oops. I put it in the wrong spot. There we go. And this time it is false. Okay, but what I do want to illustrate is sorted compared to true is the same as sorted itself, given that sorted is a Boolean variable. Does that make sense?
Why?
Well, let's take a look. Okay. So we have a variable called sorted here. Okay. As a Boolean variable, how many values can it assume? 2. It can have only up to 2 possible values, right? It can either be true or it can be false. Is that okay so far? I cannot do this with an integer variable because there's an infinite number of integers. But with a Boolean variable, I can spell out all possible answers. There are only 2. So I use this as one column. And I now look at another column. Sorted equals to true. I actually do the comparison. What is the result of sorted equals true when sorted is in fact true? True equals true is true. Okay, very good. Okay, what about when sorted is false? False equals true is false. Do you see any pattern here? The first column, which is sorted all by itself, and the second column, which is the result of the comparison, sorted equals true, they're exactly the same. Now, when you see two columns being exactly the same in terms of Boolean logic, that means they are truly equivalent. You can use one in the place of the other. So in this case, my original code had this form, which is not wrong. It is perfectly fine. It is correct. But I can simplify that to just sort it itself. Okay. Are there any questions about this? No questions? And we have just run over by 1 minute or so. So I'll see you guys on Thursday. And don't forget, Thursday is exam 1. So get ready for the exam.